Alright, we're looking at how to invert a balanced binary search tree in Python using functional programming paradigm. So we import data classes and type in these two libraries. They make our life easier while dealing with different data types, null values, missing values, etc. etc. So we define a class tree node with frozen set to true, which means it is an immutable tree node using frozen data class. Value integer, the value to be stored, and to child left and right, which are optional, initialized as none, so they can be empty or none. Then we define invert tree root, which is also optional, and the output of this function um, can be none as well. So if root is none, we simply return none. Otherwise, we do the recursive call, return tree node, value equals to root dot value left equals to invert tree root dot right, and right equals to invert tree root dot left. This is where the swap is happening. So left becomes inverted right, and right becomes inverted left. Simple. Then we have an alternative using higher order functions. So higher order function meaning function calling another function. So we have once again root optional to optional, um, and within this invert tree HOF we have transform node, and within this we are returning tree node value once again node dot value left invert tree HOF node dot right, and right invert tree HOF node dot left. Return transform node root if root, else none. And we are using tree fold. This is using fold reduce pattern for tree transformation. So here we have if tree is none, return leaf value, otherwise return node function tree dot value tree fold, tree dot left leaf value node function, tree fold, tree dot right leaf value node function. So it is taking these three parameters, tree, then leaf value and node function, and calling it recursively. Now we define invert tree fold. So inverting using this fold pattern, define combine value left result and right result, return tree node, value is the value that has been passed as in the argument, and left equals to right result and right equals to left result. Then we return the tree fold, root, none, combine. Then we have create sample tree. So we are creating a simple sample binary search tree, 4 as a root, 2 left tree, left child, 7 right child, 1 3 6 9. So it is a simple 7 elements binary search tree. Then return tree node values to 4, so left equals to tree node, so recursively creating and returning the tree with the root 4 as its root. Then we try to do the print in order, so to visualize the tree. If not root, return empty, otherwise return print in order root dot left plus root dot value plus print in order root dot right. So let's take a look how the implementation is tested if name equals to main. So under this we have all the test cases. So original, create sample tree, print original tree in order, then inverted one, inverted tree, and inverted two using the fold mechanism, invert tree fold. All right. So we're going to run this on Google Colab. We have everything here, the invert tree and invert tree with higher order function, the threefold. So here as you can see in the output, so original tree 1 2 3 4 6 7 9, there is no 5, no 8, so we have this 7 element balanced binary search tree. And inverted tree we then go for in order, and we have 9 7 6 4 3 2 1. And also using fold inverted tree we have the same in order 9 7 6 4 3 2 1.